Alright, in this video we're going to write the equation of an ellipse in standard form. We're actually going to break this one up into two separate videos to help control the length of each one. So example 2, find the equation of the ellipse with foci at 2, 1 and 4, 1 and a vertex at 0, 1. So much like with the example in the last video, let's graph what we can and get some kind of visualization of what's going on in this problem. So we'll graph the two foci. We have 2, 1 right here and 4, 1 right here. And then one of the vertices, or a vertex, at 0, 1. So remember from the last video that the center is going to be in between, in the middle, the midpoint of the vertices, and then the midpoint of the foci. So we can find the coordinates of the center by taking the midpoint of the foci, or just average the x's and average the y's, and when we do that we get a center at 3, 1. So the value of c, which is the distance from the center to a focal point, is 1, and then the value of a is 3, going from the center to a vertex, which means we can find the value of b, or b squared in this case, by taking 3 squared minus b squared equals 1 squared. So when we simplify this, we get 9 minus b squared equals 1. Subtract 9 from both sides, we get negative b squared equals negative 8. And then divide both sides by this negative 1, we get b squared equals 8. Now, we could take the square root of both sides, however, we're just trying to find the equation. And for the equation, we need the coordinates of the center, which we already have, h and k, or 3 and 1. But we also need a squared, and we also need b squared. Well, a is 3, so 3 squared is 9. And we already have b squared, so we can stop right there at 8. If we took the square root, we would just have to end up squaring it again anyway, so rather than go through that, let's write our equation as x minus 3 in parentheses squared over 9, 3 squared is 9, plus y minus 1 in parentheses squared over 8 equals 1. And by the way, we know that the larger number 9 has to go below the x because our vertex is to the left of our center, which means our ellipse is going to be more wide or wider than it is taller. Right, so writing the equation of ellipse, that is to write the equation of ellipse in standard form, a lot like that how we did for circles, where we found the vertex of the x coordinates, the vertex of the y coordinates, and added the absolute values of the y coordinates to both sides. So find the center, the lines containing the major and minor axes, the vertices and the endpoints of the minor axis, and the foci for the following. So first thing we're going to do is we're going to transform this equation to make it look like the equations we've been doing. So we'll start by subtracting the 33 from both sides. We'll get x squared minus 2x plus 4y squared plus 24y equals negative 33. So looking at the x terms in red and the y terms in blue, our vertex for the ones in red are going to be at 1, negative 1, and our vertex for the ones in blue are going to be negative 3, negative 36. And again, if you want to use a graphing utility to do that, graph x squared minus 2x, you'll get this vertex in red. Make sure you graph it as 4x squared plus 24x, so you get this vertex here. Otherwise, you'll get negative 36, negative 3, and then you would have to remember that it's actually, if you don't change the y to an x, that the negative 3 is actually the value of k. So we have a 1 in front of the x squared, so 1 times x minus 1 squared, plus the 4 that's in front of the y squared will bring down 4 times y plus 3 squared equals, we have negative 33 plus the absolute value of negative 1 plus the absolute value of negative 36. So when we simplify the right-hand side, we get x minus 1 in parentheses squared plus 4 times y plus 3 in parentheses squared equals 4. So with ellipses, we want the right-hand side to equal 1, which means we can just divide everything on both sides by whatever's on the right, in this case 4, and simplify. And our equation in standard form, which is going to make everything else, finding everything else a lot easier, is x minus 1 in parentheses squared over 4 plus y plus 3 in parentheses squared over 1 equals 1. So looking at the values of h and k, our h is 1, our k is negative 3, so the center is at 1, negative 3. A squared is going to be the larger denominator, and this one is because 4 is the bigger denominator and it's below x. Our ellipse is going to be wide. So a squared is 4, which means a is plus or minus 2. So to get our vertices, since our ellipse is wide, we're going to add and subtract 2 from the x-coordinate of the center. And when we do that, we get negative 1 for 1 minus 2, comma negative 3. And then we get 3, comma negative 3 for 1 plus 2. Our major axis is going to be y equals 3, or excuse me, negative 3. Our covertices, we have the smaller denominator was 1, so b squared is 1, which means b equals plus or minus 1. So we're going to add and subtract 1 from the y-coordinate of our center, so 1 and then negative 3 plus or minus that 1 will give us covertices of 1, negative 4 and 1, negative 2. And our minor axis is going to be x equals 1. For our foci, we have c squared is a squared was 4, b squared is 1. So c squared is going to equal 4 minus 1, which is 3. And when we take the square root of that, we get c is the square root of 3. So again, because our ellipse is wide, we're going to add and subtract the square root of 3 from the x-coordinate of our center. So because they're not like terms, we'll just leave it like this. Or you can make it 1 plus square root of 3, comma negative 3, 1 minus square root of 3, comma negative 3. But this one's just as fine as well. Alright, that about does it for this video. In the next video, we'll talk about eccentricity. So I'll see you then.